For the start of simplifying radicals, we're going to want to be able to have memorized the first set of perfect squares and the first set of perfect cubes. So take a minute, fill out this chart, pause the video, and when you're done, come back. Welcome back. So we filled out the chart with our perfect squares and our square roots and our cube roots. So just to discuss, we are talking about inverse operations. So I'm going to scroll down here to the bottom where we have this little bit of space. So you guys can write this on the space. For our inverse operations, if we want to undo addition, what do we have to do to undo addition? Subtraction. If we want to undo, let's say, multiplication, what are we going to do? Division. Good. Now, this is where we're going to be working with our exponents. If we have an exponent, if we've squared something, how do we undo that? Square root. And that symbol looks like this. If we've cubed something, if we've cubed a number or a variable, how are we going to undo that? Cube root. And that's what we're going to be doing now. So we've been working with exponents. We've learned all the rules of exponents. Now we're going to learn all the rules of square roots and cube roots and how we can use those to simplify or manipulate expressions. Okay, to learn some of the rules of radicals, we're going to open up our Desmos testing calculator, and we're going to go ahead and try using this table method. So everyone type in the word table. Okay, and for our, instead of, you see A and B here, we're going to use X and Y. So we'll do 3 and then 2, and then go ahead and click up next to Y1 into a new column. And we want the square root of A. So we're going to, or square root of which would be X. So we're going to type SQRT. The square root symbol shows up, and we want the square root of this column. So we're going to say X1, and we'll just type in an X1, and it gives us that number. Then we're going to go over and we're going to click next to that, and we want the square root of B, which for us was Y1, and it gives us the answer. We're going to go over to the next column, and in this one we want the square root of X1, and then we want it times the square root of Y2, but we got to scroll out. So you have to scroll right and do square root of Y1. All right, the next column that we have here is the square root of the numbers multiplied after. So we're going to go over to the next column, and we're going to do the square root of X1 times Y1. Now, you don't need the times symbol. It will understand if you put X1 next to Y1. I believe it. Yeah, it understands X1 times Y1 there. Now, I'm going to just change my screen so we can see the whole table at once. So we can scroll this graph because we don't really need the graph part. We just want to take a look at the table. And you're going to copy down, let's copy down up to 3 digits, okay? This table. So 3, 2, the square root of 3 is really 1.73. The square root of 2 is 1.414. And then you're going to write down these numbers. And then you're going to complete the table. So you're going to use the practice sheet there, write down the digits for the next several. Okay, when you're done with that, go ahead and pause the video, and then when you're done, come back. All right, so here we have the values filled out to 3 decimal places. And as you guys have noticed, what do we notice about these last 2 columns? What's the pattern? They're all the same, right? So if we break up the square roots and multiply them, or if we put the numbers underneath as both the radicand and multiply, we get the same answer. That's the rule that we're going to be applying today to simplify radicals, is what we say. Okay, so you can go ahead and put your computers away. We won't need those anymore. And let's go to our notes. And there we are. Okay, so for our notes, all right, so we noticed that the product of the square roots and the root of the products are the same. In other words, our rule is that the square root of a times b is the same as the square root of a times the square root of b. The opposite or converse is also true. If you have two square roots separated from each other, you can combine them. All right, so let's just talk about some of the names of the symbols. When we're working with this symbol, we've called it the square root symbol, which is accurate and correct. We're going to also call it a new name, and it's called the radical symbol. The inside is called the radicand. The whole thing is called a radical expression. An expression with radicals in simplest form is in simplest form if we have these three things. There's no perfect square factors other than one in the radicand, so no perfect square numbers in here. No fractions are in here, and no radicals appear in the denominator. 2 and 3 are practically the same thing. They're the same rule. We'll see how they can be a little bit different. And I just realized we didn't talk about the division. Okay, so we've talked about the product property. We're also going to talk about the quotient property. The quotient property states if you have the square root of a over b, so you have a fraction, you can break this up to the square root of a over the square root of b. Okay, and our goal today is to practice this. So we're going to be practicing multiple scenarios, and we've got some practice problems here. In order to work with the practice problems, and we're dealing with the squares, we're going to list the first 20, well, actually, let's only list the first 10. The numbers aren't too big on this paper. We're going to list the first 10 perfect squares. So we've got 1, then 4, then 9, then what else? 16, then good, then good, then good. Keep going. 100. Okay, we're going to stop there only because this paper doesn't have really large numbers. Okay, so here's our example up here of what we're doing. We're simplifying the square root of 40. 40 is not a perfect square, but we can break it up into a perfect square and a non-perfect square. We want the largest perfect square we can find as a factor. So then we break it up to the square root of 4 times the square root of 10. We know the square root of 4, so we go ahead and take the square root of 4, and then we have the square root of 10. Okay, so that's what we're working with today.